The Sun, a massive star, is located at the center of our solar system and is the source of energy that sustains life on Earth. This majestic giant has a diameter approximately 109 times the size of Earth's. The Sun's perfect combination of numerous elements, hydrogen and helium being the most abundant, provides an internal heat source that greatly affects our solar system. The Sun is a composition of gaseous and charged particles, which is known as plasma. The core of the Sun is at the Sun's center. It is the hottest layer of the Sun and the solar system, reaching temperatures of around 15 million Kelvin. In this layer, nuclear fission occurs to produce energy.
The radiative zone is the next outward layer of the Sun. Photons carrying energy travel through this layer in about 100,000 years. The photons travel using radiative diffusion, which is why it takes so long.
The next layer is the convection zone. Photons travel outward quicker through this layer because instead of traveling through radiative diffusion, they travel through the process of convection. The convection zone is named so because as hot gas travels from the outer edge of the radiative zone to the outer edge of the convection zone, the plasma cools. As it cools, it gets more dense and sinks. It then heats up again and the cycle continues. This creates the visual image of the Sun's boiling surface called granulation.
The next four zones are the Sun's atmosphere. The first is the photosphere. The photosphere is the most opaque layer of the atmosphere, so it is generally thought of as the part of the Sun that the solar light that we see appears to be emitted from.
Next is the chromosphere, a layer of decreased density. This layer of the atmosphere is strange as it gets hotter as you go out. This is due to metohydrodynamic waves. These waves are created when magnetic lines are displaced. As the lines try to move back, it oscillates and releases energy, thus producing heat.
The transition zone has a generally increased temperature compared to the chromosphere. Heat flows down from the corona into the chromosphere, and in this process produces the transition zone.
The last layer is the corona. It is a very thin and hot layer that is responsible for solar flares, coronal mass ejections, and solar winds.
The Sun generates its heat through a complex reaction. This is basically how it goes. The Sun's core is so hot, about 15 million Kelvin, and has so much gravitational pressure that the hydrogen gets broken into electrons and protons.
The protons fuse under pressure and create photons, which essentially converts mass to energy, thus producing abundant amounts of energy.
Some of the energy produced is the visible light we receive on Earth. The other is used to generate the magnetic field.
For the visible light to reach Earth, the photons first travel through the radiation zone, which takes 100,000 years. The photons are bounced around in this zone, which is why it takes so long. They then travel through the convection zone in a much shorter time because of convection. Eventually, the photons reach the edge of the Sun. From there, it takes 8 minutes to reach Earth.
The Sun would have similar magnetic field lines to the Earth, running north and south. However, because of the Sun's plasma and rotation, the magnetic field lines do not run directly north and south. The lines go crazy and eventually may result in solar flares. When the magnetic lines pop out of the Sun's surface and their north and south poles cross, result in an explosion.
These solar flares are strongly correlated with sunspots. Sunspots are darker colored areas in the sun's photosphere. They appear darker because they are around 1000 Kelvin cooler than the surrounding area due to a 1000 times stronger magnetic field there, not allowing as much heat. Sunspots normally come in a pair of opposite magnetic charges.